Thank you for your kind introduction. I am Kenneth Lam, and this is Professor Mike Pat from University of Maryland. And we are from CAiRS. CAiRS stands for Center for Advanced in Reliability and Safety. So let me pass the time to Mike.
So when we buy a product or use a product, we expect it to be reliable and we expect it to be safe. But this isn't always the case. Actually, last week when I came to Hong Kong and I was going through the airport, half of the escalators and half of the moving walkways were not working properly. That's not a safety issue, it's just an inconvenience, especially for somebody who has a bad knee. If you look at what's happened in Hong Kong over the last year, I think we all know there's been train accidents, there's been problems with elevators, there's been fires in electric vehicles. Those are safety issues. And they're not unique to Hong Kong, but they are a very important thing to be considered. The University of Maryland, my university, is the only university in the world that offers an undergraduate, master's, and PhD in reliability and safety. And what we've done is worked with CAiRS now to try to transfer this kind of information and educate people and help companies make reliable and safe products. We want to make products that won't fail, and we want to do this by putting a doctor on the shoulder of the products that they develop. And this doctor is quite different than the doctors that you've been hearing about previously, especially in the last session. Our doctor is an artificial intelligence system of sensors and physics of failure-based algorithms that can detect the health of the product, predict when failures will occur, and forecast maintenance so that failures will never occur. And this is especially needed in all of Asia. I visited thousands of companies in Japan, Taiwan, Philippines, Thailand, and in mainland China and Hong Kong. And one of the things that I've noticed is that reliability engineers are lacking. Many of them are my age, in the 60s and 70s. They're trying to keep them on, but they're retiring. And there's no program to help support the industry. So what CAiRS is doing is providing the tools, the services, and the education to help these industries and support the next generation.
Thank you. So here I would like to share with you some projects from CAiRS that can avoid the accidents. So don't worry, we will make Hong Kong very safe and also reliable. Now, the first project is on smart public utilities, which can detect the health condition of underground power cables. In high-density urban areas, electricity supply mainly relies on underground cables. The cables themselves are very reliable, but they are buried in the underground. At the presence of electrical stress and water, a defect called water trees may be formed in cables. Now, this will gradually degrade the insulation of cables, leading to breakdown and finally power outage. Now, we use sensors on cables to measure some important electrical parameters and also employ advanced machine learning models to perform classification. We can detect the status of cable and also the remaining useful lifetime of cables. This project can help avoid unnecessary maintenance and unexpected failure of power cables. Now, the next project is on smart transportation. Now, we have developed an AI computer vision-based system that can perform real-time rail track defect detection. Now, our system can achieve a precision rate higher than 99% and also reduce the false alarm rate by more than 88%. Now, another project is on smart manufacturing. We developed a system which can perform soldering defects. Detecting the defects is very challenging. A circuit on PCB with the defect may still work properly, but the lifetime is very short. Now, when a PCB with the defect, and we may find that the PCB temperature may rise abnormally. Therefore, we devised a thermal imaging-based system to predict the failure of soldering. Now, the last project is on smart building. Now, every building also have lift. Now, and the reliability and safety of lift have always been a concern. Existing methods, okay, based on manual inspection. Now, so here, once again, we use a non-destructive detection method by measuring the magnetic field leakage to perform accurate detection. Now, currently, CAiRS has 41 industrial collaborators. Now, we help our collaborators to further improve the reliability and safety of their products and systems. Now, based on our projects, we now have 16 patents. Now, and finally, remember that CAiRS cares you. With CAiRS, we build a reliable and safe city. Thank you.